All right, lately we've been solving for x, right? We've been finding what x is equal to, and we're going to kind of do the same thing, but we're not really going to find what x is actually equal to this time. Well, kind of. What we're going to do today is we're going to deal with things called inequalities. So what do you think of when you think of something that's an inequality? So for instance,
Something that's not an equality.
right. So if I had something like this, that would be an equation, right? Equation, right? Did I spell that right? So this is an equation. What would this look like as an inequality? What do you think?
All that does not equal to?
Okay, you could say does not equal, but we have something else. No, it wouldn't be another variable necessarily.
Unequal.
Less than or equal than, or less than or greater than, right? So I could say less than 2, or I could say greater than 2, right? Or I could say, what else? Less than or equal, right? Or greater than or equal. Do you remember those symbols? Right, so if I had this, if I had A and B, and I had this symbol right there, what is that? That is A is what? Less than B. Now, when you're a kid and you learn this, and whenever you learn this, elementary, late elementary, early middle school, something like that, I don't know, I've heard some kids, I never taught it like this, but I heard some kids that tell me, oh yeah, that's the one where the alligator eats the bigger number or something like that, you know. And that's cute for 5th grade or 4th grade or whenever you learn this stuff. But this is how I look at it. I look at it like this. This is an equal sign, correct? Actually, tell you, yeah, we'll just do it like that. No, change my mind. Let's do it like this, watch.
Make up your
So
mind.
I am making up my mind. Give me a break. All right, so here we go. Here's an equal sign right here. And watch, they're equal distances. Do you see that? They're parallel to each other, right? That's an equal sign. Would you agree? Okay. So watch this. So what is less than? Well, less than would be, let's see if I can do this. There we go. So less than would be if I did this. Do you see that the distance, rotate, there we go. Watch. Do you see that? So that's a less than. What do we do? Look, there's a greater distance between these two than between these two. Would you agree? All right, so this is smaller than this, right? Started off as an equal sign. Would you agree? Started off the same distance apart, right? But now we made this one smaller and this one bigger, so this is what? This is less than. If we did it the other way, then what is it? Then it's greater than. Okay. I don't know if that helps you remember it or not, but I don't know, it's kind of interesting to see. An equal sign is the same distance apart, right? With the actual symbol. But look at this. This is greater than because this is now greater. The distance between the 2 points, right, is greater here than it is here. Make sense? So it's greater than. I don't know if that's makes it any easier or not, but that's how I kind of look at it sometimes. But a lot of people get confused between which one is less than, which one is greater. So this is A is less than B. For instance, 2 is less than 5. Would you agree with that? You could read it the other way too. You could read it from right to left. How would I read this from right to left? 5 is what? No, from right to left. 5 is greater than 2. Isn't that saying the same exact thing? Yeah, absolutely. So if I had like this, if I had x is less than 3, I could read it like that, x is less than 3, or I could read it the other way. I could say that 3 is greater than x. A lot of times we don't think about reading it from right to left, but sometimes that's kind of helpful. All right? So we okay with that? With the less than, greater than? I don't think I have to go through a whole entire lesson on less than and greater than. It's stuff that you've learned for many, many years now. You should have. We're just going to take it just a little step further today. All right, let's go back to the equations. Let me let's just do one. This is an example from the book. Now, if I asked you to solve, for x right here, we're not going to get exactly just one answer for this. We're actually going to get an infinite number of answers for this. You'll see that in a second. But watch very carefully. And I tell you what, before we do this, I mean, you can keep this down, but off to the side maybe, write this down. What if I had this? What if I had x plus 2 is greater than 5? Okay, I said, let's just forget about that. Let's just do this one right here. If I had just x plus 2 is greater than 5, we'll start off super easy before we get to the one that's a little bit tougher. if I wanted to solve for x right here, I would do the same thing as I normally would do if this was an equal sign. Okay, if this was an equal sign, what would you do? You would just subtract 2 from both sides. Everybody good with that? And so x is greater than what? 3. Now let's see if that's really true. Let's check, right? The last day or two we've been checking our answers, haven't we? So let's check. It says x must be greater than 3. So let's pick a number. Don't pick a crazy number. Pick a nice easy number that's
10.
bigger than 3. 10. Okay, put a 10 in here. So that means this must be true. If I put a 10, because 10 is greater than 3, if I put it in for this thing must be true. 10 plus 2 is 12. Is 12 greater than 5? Yeah, absolutely. Let's try one that's not greater than 3. Give me a nice easy number that's not greater than 3.
1.
Okay, 1. Okay, we'll pick 1. So put a 1 in here. 1 plus 2 is 3. Is 3 greater than 5? No, it's not, so that doesn't work. What if we stick a 3 in there? What if I put a 3 in here? 3 plus 2 is 5. Is 5 greater than 5? No, 5 is equal to 5. It's not greater than 5, is it? All right? So far, we're good. I mean, really, the math is no different than if this was just a regular equal sign. Would you agree with that? All right, it's no different at all. But what if we did this? What if I said negative x plus 2 is greater than 5? Let's do the math here. Subtract a 2, subtract a 2. Bring down the negative x, that cancels out, is greater than, what's that? 5 minus 2 is 3. Now what would we do to get rid of that negative sign?
Switch the direction of the
Yeah,
thingamabobber
that's not really the question.
and
How do we get,
multiply
listen.
it by negative.
I want you to answer my question. Okay, you're getting ahead of me, and I'm not saying that you're wrong. I just want you to answer my question. How do we get rid of this negative right here? Yeah, so technically it's like a negative 1 in front of this, right? So how would I get rid of a negative 1 times x? How would I get rid of that negative 1?
Multiply it or divide.
Yeah, you can multiply or divide. It's either way, you get the same thing.
Yeah.
I think some people would see that dividing by a negative 1 makes a little more sense. Okay, but yeah, technically you could multiply by negative 1. It still gets rid of the negative. All right, then come over here and divide this by a negative 1. So negative over negative is positive. I've got an x. 3 over negative 1 is what? Negative 3. Now watch, don't write this down because this is going to be wrong. I'm telling you right off the bat. Okay, so remember what I said over here? You work it just like if it was an equal sign. Well, over here, it's a little bit different. What if we just kept the sign the same? Now, Tiffany kind of alluded to it already, and I didn't want her to get ahead, okay, because I wanted you to see this. What if we said this right here? Would this be the correct answer? Well, let's check and see. X is greater than negative 3. So give me an easy number that's greater than negative 3.
Negative 2.
All right, we can do negative 2. All right, so let's put it into this original inequality right here. So let's put a negative 2 in for this. So negative 2 is what? Positive 2, right? Positive 2 plus 2 is what? 4. Is 4 greater than 5? Is it? No, it's not. So that doesn't work, does it? So what do you think we're going to do? We're going to switch the inequality. Exactly right. All right. And I like to show why this works. Okay, instead of just saying, okay, this is the rule, this is what you do. I like to see an example. If you would have kept it the same, it wouldn't work, would it? So what did I have to do? I have to switch it. Now let's see if that actually works. X is less than negative 3. So give me an easy number that's less than negative 3.
Negative 4.
Negative 4, that's good. Okay, so let's put it in for this. Negative 4 is what? Positive 4 plus 2 is 6. Is 6 greater than 5? Absolutely. So that does work, doesn't it? You can pick any number that's less than negative 3, and it's going to make this inequality. It's going to satisfy the inequality, is what they say in math sometimes. Does that make sense? All right, so that's the only time when you change the inequality. When do you change the inequality? Look what we did right here. We divided by a negative, okay? And it's not just because it's a negative 1, but because it's a negative. Now, I could have multiplied by a negative. So anytime you multiply or divide by a negative, that's when you change the inequality. Remember that rule from before? Probably learned it in pre-algebra, algebra 1, algebra 2. You probably have done it several times before today. All right? This is just a reminder for you. So if you multiply or divide, you might want to write that down somewhere. I didn't write that down. If you multiply or divide by a negative, you must change the direction of the inequality. Do you see that? We went from greater than to less than. And why did we do that? We did it because we divided by a negative. Or if you multiply by a negative, the same thing. Now, are you allowed to subtract and keep the inequality? Yeah. You can subtract things from both sides. You can add things. You can multiply and divide as long as you're multiplying and dividing by a, what do you think? You can keep the inequality the same if you multiply by a, what kind of a number? A
Positive.
positive number. You can keep the inequality the same if you divide by a positive number. When you change it, when you change from a greater than to a less than, or the other way around, from less than to greater than, you must change, you do it when you divide or multiply by a negative number, okay? So anytime you multiply or divide by a negative number, that's when you change the inequality. So with all that said, that was kind of like a precursor to all this. So let's go back to this problem, and let's see if we can get a solution for x. So let's do this. First step, minus 5 from both sides. This is just like a regular, normal Algebra 1 problem, isn't it? Okay, except we have to just consider the inequality. So that subtracts, there it goes to 0, so I bring down negative 3, so it's negative 3x is greater than negative 12. Now I didn't change the inequality here, did I? Because all I did was subtract. And I can subtract things from both sides and I don't have to change the inequality. Now we got one more step. What do we do here? How do I get rid of that negative 3? So divide by a negative 3. Let me do that in yellow since I did the other. So we have to divide by a negative 3. So we come over here and divide by a negative 3. Well, what did we just do? We divided by what kind of a number? A negative number. What does that tell me I do with my inequality? I got to switch the inequality. That's right. So that's just an x. I got to switch the inequality, and then I do the algebra here, or the math there, and it's 4. Okay? You can always check to see if it works. You know, it should be fine. Pick a number that's less than 4. Pick an easy one, like 1. Negative 3 times 1 is negative 3, plus 5 is 2. Is 2 greater than negative 7? Yeah, positive 2 is greater than negative 7. So yeah, that works, doesn't it? And we're good to go. All right? Now, what we're going to do now is we're going to graph this thing. Remember graphing in Algebra 1 and Algebra 2? Did a lot of this stuff, and you did it in Algebra 1 as well. We're going to graph it. Now, it's only one variable, so you don't have to worry about rise and run and all that kind of stuff. All you got to do is just graph along one axis, and this would be the x-axis. It says x is less than 4. So watch what we're going to do here. 1, 2, 3, 4. So we're going less than 4, right? So I want the 4 over here. 2, 1, 0. You don't always have to have a 0 in the middle and then go negative, then go positive. A lot of people do that, but sometimes that's just a waste because you don't really need all that. All you need are these numbers right here. If it says x is less than 4. So what do? Do you remember this? We put some kind of a dot at 4. What kind of a dot do we put?
Line.
Or a circle. It's an open circle. That's right. How do you know it's open? Because there's no or equal to. That's right. If it said or equal to, then you would color in the circle. Okay? But if it just says less than, so we just put a circle at negative 4, and then what do? We color in, don't we? Remember that? We color in to the what? We go to the right or to the left? Well, it says less than, so it's pointing to the left, so we color everything to the left. Agreed? We color everything in. I just kind of do it like this. Now, some people teach like this. You go over like that and like that, right? But I don't know. I like to darken in the number line. Is that how you were taught to do it like that? Yeah. So this is an open circle. Why is it open? Because it's not or equal to. If it said or equal to, then what would you do with that circle right there? You'd close it in, color it in, right? Make sense? All right, so it's everything to the left. Now this is kind of like the old-fashioned way of doing things. This is like the high school Algebra 1, Algebra 2 kind of way of doing things. When you get to college, and that's what we're doing college algebra, and I actually talked to Mrs. Bonsbach because she taught at Del Tech for several years, and I just wanted to get her point of view on this. And she said, yeah, in college you do it this new way that I'm going to show you. Watch this. It says x is less than 4. Take a look at this graph. What I'm going to do is I'm going to show you a thing called interval notation. Interval notation. I'm going to show you the graph first. Notation. Alright, this is called interval notation. This is how I'm going to want you to write your answers. Not like this. We're still going to do a graph, and it's going to look very, very close to this. Alright, but I'm not going to have you write it exactly like this. And I'm not even going to have you write your answer like this. See how it's circled? We're not really going to have you write your answer like this. Your answer is going to look more like your graph. I'll show you what I'm talking about. Here we go. instead of an open circle, this is what they do for interval notation. They use like a parentheses. And notice, since this thing is all going to the left, my parentheses is kind of facing the left. Do you see that? It's closing in everything on the left. Make sense? So instead of an open circle, we're going to use a parentheses. Now, if it was a closed circle, we would use a bracket. Okay, I'm going to jot that down. So an open circle, so we use a parentheses instead of an open circle. And we use a bracket instead of a closed circle. Everybody good with that? That's really the only thing different as far as the graph is concerned. All right? Let's just copy and paste this so I have to redraw it. Okay, let's get rid of all that. Let's get rid of that. Let's get rid of that. Okay, there's my graph again. So let's redraw this graph, but let's do it in this interval notation. All right, this is kind of part of the interval notation. So instead of an open circle at 4, what are we going to put? A parentheses. Do you see that? And since we're going to the left, this parentheses is facing the left. That's really the only thing different as far as the graph is concerned. Okay? If it was a closed, if it was less than or equal to, you'd put a bracket there, wouldn't you? All right, and then you just shade everything to the left again. All right, so the only thing different on the graph is putting a parentheses instead of an open circle. That's not so bad, is it? But what I want you to show you now is really the interval notation. Here's how we're going to write it. We're not going to say x is less than 4. This is old. All right, that right there is old stuff. All right, we're going to do it a little bit of a different way. We're going to write our answer a little bit different. If you look at this, look at all the possible answers that we have. It's every number that is less than 4, and it keeps on going. How far does that keep on going? All the way to where? Infinity, that's right. But we're going to the left, so you actually have to the left is what? Negative infinity, and to the right would be, what do you think? Positive infinity. So if I go all the way as far as I can go, do you remember the infinity symbol? Looks like a yeah. I have a hard time writing a regular 8. Upside down or sideways 8 is even harder. But yeah, my infinities are pretty ugly, but you get the idea. You could put a couple circles there next to each other, whatever. That's kind of a girl way to do it, though, I think. So if you're a girl, it's fine. But so this is negative infinity, and this is positive infinity. So watch what this does. My answer. Remember I said earlier you have an infinite number of answers? Because look, it's not just one answer. It's any number. It's any number as long as it's less than 4, right? As long as it's less than 4, and it could keep on going forever and ever. Now look at this. Do you see this negative infinity? And do you see this parentheses right here? This is what my interval notation is going to look like. So watch. Instead of writing it like this, this is how we're going to write it. We're going to write negative infinity, then put a comma, and then we're going to put an open parentheses. Actually, I'm sorry. I've got to put a 4 here, right? And we're going to have an open parentheses on this side. Now, what about this? Are we going to put a bracket or a parentheses if we keep on going? Do you ever get to a point where you actually get to negative infinity? Can you ever get there? No, you can never get there. So, is it closed? Because if it was a closed circle, right, or a bracket, you could actually stand on it and be there. Can you actually stand and be at negative infinity? No. So what kind of a symbol are we going to have here? It's not going to be closed. It's going to be, what do you think? It's going to be open, and so open would be a parentheses. And see how they're both facing towards each other? And that's how we're going to write it. So instead of writing x is less than 4, this thing right there means exactly the same thing. It's just a different way to write it. And according to Mrs. Bonsbach, in college algebra, and she's taught college algebra in college, okay, in real college. And this is how they write it. Make sense? What's that? You put a slat, say it again? Oh, is that right? Okay, good. So you've seen it already. Yeah, what if we had something like this? What if we had x is greater than or equal to negative 3? First of all, let's graph it real quick. I'm running out of time, but let's graph it really quick and use the interval notation. So x is greater than negative 3. So that would be, I don't know, -4, -3, -2, -1, 0. So if it says greater than or equal to, what kind of a symbol are we going to have at -3? It's going to be closed, isn't it? So in interval notation, it's a bracket this time. And it's going to the right because it's greater than, so we just kind of shade it to the right, put an arrow there, and that's how we graph it. That's our graph. Okay, so that's a new way of graphing. But now we want a new way to write this. Look at your graph and it tells you how to do it. It's pretty easy. Watch. You put a bracket there. Where do we start? -3, and we put a comma, and we go all the way to where? Positive infinity, right? Because it keeps on going forever, doesn't it? So we put a positive infinity. What kind of a symbol do we put at positive infinity? Put a parentheses, because remember, at infinity, you can never get there. It's always open at infinity. Okay? What if we had something like this? I know. What if we had something like that? You've seen that before, haven't you? This means x is between. Watch this. Just put a -1 here and a 5 here. If we were to graph it, what would it be? X is greater than -1, right? So we put a parentheses here, a parentheses here. We shade, I should do this in another color. We shade everything in between. But how would I write interval notation with this? It's easy. Look at the graph. The interval notation looks almost identical to the graph. You put a parentheses and a what? A -1. Put a comma and a 5 and close it, and that means the same exact thing as that right there. But it's kind of a nice way to do it because it looks really, really close to what the graph looks like, doesn't it? All right, let me give you a worksheet, then you can go.